We're doing good. I'm gonna fly through this. This is your article-specific content for this week on sedentary behavior and its effect on mortality. So, just as a heads up, this article splits sedentary behavior into total sedentary behavior and TV viewing. So, I'm going to present some data in class next week that talks about a variety of sedentary behaviors. So, we talk about type of physical activity in terms of mostly aerobic physical activity and resistance activity. In the sedentary behavior world, we might talk about an active sedentary behavior or a passive sedentary behavior. So, for example, listening to this lecture would be considered an active sedentary behavior. You're trying to learn new material. If I'm reading a book, that would be an active sedentary behavior. If I'm watching TV, that would be more of a passive sedentary behavior. And it appears that the type of sedentary behavior impacts or changes the impact of sedentary behavior on my health. Okay, so not all sedentary behavior is created equal. So a couple terms that you will come across in the research that I want you to be aware of. So primary research is a term that they use. Primary research just means that the researcher collected the data. So for example, my thesis research used NHANES data. That would be a secondary analysis. They say that they conducted the meta-analysis using primary research only, meaning all of the investigators who publish these papers that they're reviewing collected the data themselves. Okay. Death registries is another thing that comes up. These are official documents that verify a person's death and contain information such as the date and time of death, cause of death, the signature of the attending physician. This data is not always public, just for the record. So researchers have to often request approval. It's on a state-by-state basis. So I think Massachusetts, it's public data. So as soon as somebody dies, we create a death registry or we add to the death registry and it's accessible to anyone. In Utah, you have to request access. So I think data becomes public after 50 years after death, but not immediately after death. So if a researcher wanted to do epidemiologic research in Utah, they would have to request access to the death registries. Reverse causality is one of the problems with retrospective cohort data. So and they mention it here. The idea is that if I develop a disease, it may then increase the propensity for a risk factor as well. So let's say I developed type 2 diabetes. If I develop type 2 diabetes, that may increase my likelihood of engaging in increased sedentary behavior. So it may be that the disease caused increased sedentary behavior rather than sedentary behavior increasing the disease. And so they talk about how they're trying to be careful about preventing reverse causality assumptions. Okay. Jumping into statistics, so a couple things I want you to be familiar with. Harmonized data just indicates that they made it possible to combine all of the data. So let's say I was talking about physical activity, or let's use sedentary behavior since that's the article. If I was measuring someone's sedentary behavior, some people may measure that in terms of hours per day. Some people may do minutes per day. Some people may do minutes per week. All that would indicate is that I've changed it so that all the data is using the same units so that that data makes sense to combine. Generalized least squares regression is linear regression that accounts for unequal variances. So it's used in analyses that measure an outcome across time because there's usually a pattern to error terms. So if I'm measuring the impact of mortality or the impact of sedentary behavior on someone's mortality across time, right, I would expect that if I measure one individual across time, right, that there's a pretty consistent error term for that individual. But across individuals, right, I would expect that there's less of a pattern to error terms. So GLS regression, it just allows you to account for the fact that there's going to be some variability to error terms, but that there's going to be consistency to error terms across individuals across time. Okay. Random effects, if you want a longer review, go back to, I believe it's week 5, where I reviewed this pretty significantly. But all that indicates is that there's a weighted average of study-specific effect sizes because effect sizes aren't uniform across studies. So the impact of TV time isn't always the same. That's all that's saying, right? We're reviewing lots of different studies, and the impact of sedentary behavior on different populations is going to be different. The Eager test is used to assess publication bias. Again, go back to week 6 if you want a full review, but basically we're trying to make sure that we're not only publishing articles that find significant results, that we would expect to find some studies that don't find any result or any significance to TV viewing and mortality. Okay. So just assessing that. Sensitivity is saying, especially, right, I'm looking at the relative risk of multiple different studies. Okay, so if I don't expect all of the relative risks to be the same. So what if I have one study that showed really high relative risk and that's affecting the average relative risk of all of the studies? I want to make sure that one study is not really affecting my results. So that's all a sensitivity analysis is you take out this one maybe outlier study and see, does that affect the results significantly or not? Your I squared is just looking at homogeneity versus heterogeneity and determining whether or not you should use a fixed effects model or a random effects model. Random effects, right? We already talked about earlier, so hopefully you understand that. If not, I'd suggest going back to week 5 material. A Monte Carlo analysis is really fun. So it's the idea that they explain it better in the article, honestly, than I will. But essentially, I have a population and I assign a relative risk to every individual in the population. But in reality, I can't measure the relative risk for each individual. And so I have to guess a little bit, right? So I've randomly assigned relative risk to individuals based on their TV viewing time. And then if I've randomly assigned, I can randomly assign again and again and again. So a Monte Carlo says I randomly assigned 5,000 different times. So now I have 5,000 different models, and I'm going to take the average of those 5,000. Okay. So essentially, it's just, again, it might increase confidence intervals. It's actually going to decrease my chances of finding a significant result. So if I find a significant result, I'm going to have more confidence that there is indeed a significant association between TV viewing and mortality in this case. Okay, confounding and mediating, we're going to cover in the next slide, as well as population attributable risk. So mediating, remember, that is different than moderating, which is mostly what we've dealt with before. Mediating would indicate that the variable that you're discussing is on the causal pathway. So the population attributable risk that we're going to talk about in the next slide assumes that a variable is on the causal pathway. So it's assuming that TV viewing is a causal factor in mortality. And then population attributable risk. So population attributable risk, or in fact, they say in the study they use population attributable fraction. It's the same thing. Okay. So how much risk for the health outcome within the population can be attributed to different risk factors. So it compares the relative risks of different risk factors, and we'll look at that specifically for the study in the next slide. The equation is here, right, where PE is prevalence, RR is, so prevalence of those who are watching TV, right? And the RR is the relative risk of disease or mortality, in this case, due to TV watching, okay? So we do some fancy math, and you can divide this into two different things. So they look at population attributable risk. What's really common, especially in drug studies, is clinical attributable risk. So this estimates the proportion of the cases of those with the risk factor that would be eliminated if the risk factor were eliminated. So the number of deaths in the TV watching group that would not occur if all the individuals in the TV group stopped, right? Because individuals who are watching TV, they still are going to die, right? It's just how many of those deaths could be removed if, or delayed rather, if all of these individuals stopped watching TV. Population attributable risk, though, would say that the total number of deaths in the total study population that wouldn't occur if the individuals who are watching TV stopped. Okay, so I would expect a much lower percentage here and a little bit higher percentage here theoretically. So just pay attention to that as you're reading. Okay, that was really quickly, or that was really a very quick overview. I hope that that's okay. Let me know if you have questions. Please reach out. Come to office hours. Ask the people who come to office hours. I think it's pretty enjoyable. I usually give you snacks and we just chat. So please, please, if you're confused, come to office hours, especially as you have your midterm coming up.